Howdy, howdy, this is Mr. Potter. In continuing to talk about our array list, there's a couple of other methods that I want to talk about, and these are primarily dealing with the contents of the array list. So I'm going to go ahead and put an import statement up here. So import java.util.ArrayList. And what I'm going to do is I'm actually going to try and create an array list from a given array. So I'm going to do an array literal here called sentence. And I'm going to set this equal to she sells C shells by the C and shore. And then what I want to do is I want to create a new array list. So array list of type string. We'll call this words. Gets new array list string. Now, there is a quick way of doing this, but it doesn't exactly give us the results we want. So don't do this. But I can say that words gets arrays dot as list sentence. And the arrays class has a bunch of good methods in it. The problem with doing this, it does create a list that we can stuff into the variable words, but it's immutable. We really can't change it, and that causes problems. So don't do this way to do it. Instead, what we're going to do is we're just going to set up a simple loop for int I gets 0, I less than sentence dot length I plus plus, and we're just going to words dot add sentence sub I. And so I should be able to go through here, and now we'll go ahead and system dot out dot print line a sentence, or not sentence, but words. And this should give us a nice Should give us a nice little array list. And so there we are. We got she sells seashells by the seashore. I chose this sentence for a reason. We're going to be traversing this later on when we in our discussion here. But I want to talk about a few ArrayList methods that really tell us something about the state of this. So I could do, system dot system dot out dot print line words dot is empty. And we've seen is empty before in some of our other objects that we've dealt with, and of course, is this empty? Well, no, it's false. If I were to take this and put it before our assignment statement, before we actually put the sentence words into the list, you see that it was true. So this is empty basically can tell us about the state of an array list, and sometimes we want to know this. We can use the isEmpty as part of a short circuiting to make sure that we don't run an exhaustive procedure if the list is empty, and doing so wouldn't really help us. There's a couple of other real good things. One of them, system.out.println, I can do words dot contains, and I can see if my array list contains like the word C. And if I run that, it's going to tell me that yes, it does contain the string C. And because it's using this dot contains, it's actually using dot equals to compare it. So it's actually comparing the strings the proper way. It's not using it's not using equals equals. It's using dot equals to compare these. And let's see, if I do system dot out dot print line words dot indexOf C C then of course the first time that C shows up is in position 2 in our list, and so we get that out. I'm curious, do we get last index of as well out of this? I know we get index of. I'm not sure if we get last index of. And the reason I bring that up is because C actually shows up twice in our list. So if I make this last index of, does that work? It does. Last index works. and it tells us the last time we see it, which is 6. So notice that I can actually see if something is in the list, and I can also check to see if I get index of or last index of, and I can do system.out.println words.index of starfish. And I bring this up because when something doesn't show up using index of, we usually get the -1, and in fact we do here as well. So I've got these 3 methods: isEmpty, contains, and index of, that allow us to see, exactly what is in the list. They're different from the add, the get, the set, and the remove that we talked about in a previous video, because those actually manipulate the contents. Here, these are purely accessors. I'm just seeing if it is empty, if it contains something, if it is, which position it happens to be in, which is good to know when we're trying to work with an array list. So that's the first thing that I want to do here. The second thing that I want to do is I actually want to create a method that's going to alter a list. So let me do this private static void, and I want to call this method remove char, or remove words. Remove words. And what I'm going to do is I'm going to have some array list of type string called list, and I'm going to have some char let. And what I want this method to do is I want to remove all words that start with the char let from list. So remember that because this is a destructive traversal of an array list, because it actually changes the contents of the array list. I don't want to use the for each loop that we talked about in our previous video. I actually want to do this using an iterator. But I want to talk about some things we have to be careful of. So I'm going to set up just the simple for loop. So for int I gets 0, I is less than list.size, I plus plus. Just a simple list, and what I'm going to do is if, and I'm going to have to get a word out of this list. So list.get sub I dot indexOf, and I can do let, and if that equals 0, then I know that position 0 happens to be the letter that we're trying to match. Then I want to do list.remove I. And so this will actually change the list by removing that element from my list. So I'm going to go through here, and I'm going to system.out.println. I'm going to put in a couple of backslash n's, and I'm going to say system.out.println before and add words. So I see what the list is before. Quit that. And then system.out.println after and add words. And in between these two commands, I'm going to have a call to remove words. Given my list of words and the char s. So what this should do is it should show me the entire string with my seashells by the seashore. Remove everything that starts with the letter S, and then print the array out at the end. So let's see if this works. List.size is a method. I need to remember that. So open and close parentheses. And these are silly mistakes everyone makes. So notice what happens here. It says before, she sells seashells by the seashore. And after I go through this loop, I've got sells shells by the inshore. I thought for sure this list would get rid of everything that we needed. So I want to talk about why this doesn't do it. What exactly the problem is. So I want to go back to what I have up here. So I had my sentence. Remember that this is, I'm going to go ahead and put a comment up here just so I can put some numbers in here. That's position 0. That's position 1. That's position 2, 3, 4, 5, 6, and 7 in our list. And we're starting off, I is 0. So we're starting off in this position. Notice that it starts with it, so we remove it. Now, when I remove it, she is gone. But that means now that this is position 0. And that's 1, and that's 2, and that's 3, and that's 4, and that's 5, and that's 6. There is no word 7 anymore. And then I plus plus, so I is now 1. So now I'm looking at this string. Notice what happened. I completely ignored this word. This word got moved to the beginning of the list. And I is 0. I removed whatever was at 0, so now I have a new 0. But then I plus plus, so now I'm looking at this position. And notice C got removed. C doesn't show up down here because I'm going to remove the 1. And if I remove it, then this is now position 1. And this is position 2, and this is position 3, and this is position 4, that's position 5. There is no position 6. And then I plus plus, so now we're looking at 2. Notice that we skipped shells as well. Shells shows up as part of this output. Now by doesn't start with an S, so we leave it alone. The doesn't start with S, so we leave it alone. I is now 4. And I want to look at C. C starts with an S, so we remove it, which means this is no longer position 4. This is position 4. And we I plus plus, so now I is 5, but my size is now 5. Notice I'm containing cells, shells, by, the, and shore. My size is 5. I is 5. 5 is not less than 5, so we break out of the loop. And the issue is this idea that once we remove something from the list, we're kind of shuffling everything down. And so there's several ways we can get around this. One way we can get around this is to kind of tamper with my loop control variable I minus to make sure, whoops, we deleted something. Let's go back in time. But I actually need to make sure that that's part of the if statement, which means I need to add braces here. And this can work, but this is ugly. The thing is, when we're dealing with the for loop, the whole idea about a for loop should be simple is that, you know, everything should be contained in this one line. This line should contain my initialization, my test, and my iteration. The thing is, I have my initialization, I have my test, but I have iteration here and here. So this is ugly. This will work. By all means, this will work, because it gets rid of everything except for by and the. Notice everything else got removed. But if I'm going to do something like this, I mean, why not just go ahead and set it up as a while loop? If I'm going to have this weird quasi iteration, I would just do int I gets 0, and while I is less than list dot size. If this is true, then remove else I plus plus. And so what happens is if it starts with it, then I want to remove. If it doesn't start with it, okay, now I'm ready to move on to the next position. So this is a second way that I could deal with this iteration. Notice it does the same thing. And this is a little bit more straightforward. As we are with our while loops, I have my initialization, my test, and my iteration on 3 different lines. And my iteration has to be within this while loop, but I still have it as part of this conditional. It only happens some of the time. And there's actually a different way that we can do this using a for loop that's a lot more straightforward. So what I'm going to do is I'm going to get rid of this iteration step here. I'm going to get rid of this initialization and test, and I'm going to do this as a for loop. But I'm going to do this int I get list.size minus 1. I is greater than or equal to 0. I minus minus. The idea is that I'm working backwards. So let's talk about what happens here. Remember, our original list had 0, 1, 2, 3, 4, 5, 6, and 7. And I'm going to start I at 7, because that's the size, which is 8 minus 1. Now, position 7, it starts with an S, so I remove it. So now I remove it. And I minus minus, so I is now 6. So the next position I check is position 6. And position 6 has an S as well, so I need to remove it. Which means my list now only has the 6 elements up to the, and I minus minus. I've got a 5. 5 is not a problem, so I leave it there. I minus minus, I is now 4. 4 is not a problem, so I leave it there. I minus minus, I is now 3. got shells. And shells is one that I need to remove. So I'm going to remove it. But in the act of removing it, this becomes position 3 now. This becomes position 4. There is no position 5 anymore. And we I minus minus. So now I'm at this 2. Notice that I've gotten rid of shore, I've gotten rid of C, I've gotten rid of shells. Now I'm looking at this C, which I'm going to get rid of because I is 2. But if this is 2 and that 2 is gone, that means this is now 2. This is now 3. And there is no position 4. And so this act of going backwards through our list, this is actually one of the better techniques of when you have to remove certain elements that fall into a certain category. Going backwards actually makes sure that you don't skip things. You can do it using a forward for loop. You just have to put that extra I minus minus in there just to make sure. You can do it using a while loop, but this backwards for loop, the idea of starting at the end and working your way back, is actually one of the better techniques to try and get rid of these elements of a list that I'll share this common idea. So, we've talked a lot about the lists here. We've talked about it from an accessor standpoint, just accessing information, where I can find something using the indexOf, or whether or not it contains something or anything at all, using the contains or the .isEmpty method. And we've also talked about some ways to traverse this loop when we need to do something that's destructive to the array list. If I need to change the contents of the array list. Remember that if I'm changing the contents of the array list, I cannot use the for each loop, which is very convenient. It's very nice. It's very short, but I can only use the for each loop when I'm just doing something passively, when I'm not changing the contents of the list at all. What we're going to do in our next video is we're going to talk a little bit about the collections class, because what the collections class allow us to do is to manipulate the values inside of these arrays in a much more effective manner, in a much more shorthand manner. We don't have to actually write our own code to do sorts. And sorting and searching can be difficult in an array list setting, because we don't have direct access with the array. We have to use get and set and remove and add. And using these collections just make things a lot easier for us. But we'll talk about that next time. Once again, this is Mr. Potter. Thank you for watching. Have a great day.